All right, so last thing we're going to look at for this week is continuing 4.1, part 2. And the whole goal of pretty much every problem today is going to be to solve a right triangle. So what it means to solve a right triangle is there are 6 things that you could potentially have to find on a triangle. 3 sides and 3 angles. We have to find all of them. Now, I have to give you some information to be able to do the problem. Since we're solving right triangles, what do you already know about every triangle we're going to solve? Yep, Angelina? It has a 90-degree angle. Okay, so that's one piece of information that you're already going to have, that you don't have to figure out. Unfortunately, because that's in every single problem, it doesn't help you to do anything. So the fact that you have a 90 is automatic in every problem. That doesn't really help us. So when I ask you to solve a right triangle, there's really 2 different situations I can give you. I have to give you 2 pieces of information to be able to do the problem. And when I say 2 pieces, I mean 2 pieces in addition to the 90. Okay, the 90 is automatic. But I have to tell you 2 other things. And I can either tell you one of the other sides and one of the other angles. Okay? One of the other acute angles, not the 90. Okay? We're not talking about the 90. Or I can tell you 2 other sides. It's going to be one of those 2 situations. Either a side and an angle, or 2 sides. So these kinds of problems, they really lend themselves to drawing a diagram, because you have to visualize what is opposite and what is adjacent. So some people can do that in their head fine. Other people need a diagram to do. So let me show you how we're going to set up our diagrams. Okay, first of all, understand that the diagrams I draw are not to scale. It's going to be the same diagram I use in every problem, just labeled differently. Once we have a diagram, then what we'll do is make a table to organize our answers. We'll have 3 sides in one column, we'll have 3 angles in the other. So here's what our diagrams are going to look like. What do we usually use to label the sides in a triangle? What do we normally call the sides? Since we don't know them, we have to pick variables. Yep.
X and Y. Or are you saying it's like on X?
I guess you could use X. You could use X, Y, and Z for the sides. It doesn't really matter. But there's a certain theorem we use that I think certain letters come up more often. Yep. Yes.
A and B.
All right. So we usually use A and B for the legs. And what do we label the hypotenuse as?
C.
C. So that's generally how we'll set up the labels for the sides. And then what kind of letters do we usually use to represent an angle in trig? We don't use letters like A, B, C. Anybody remember what kind of letters we use? Yep.
Usually like alpha and beta.
Yep. We usually use Greek letters. And the way we want to always set it up is you want alpha to be opposite A, and you want beta to be opposite B. And the reason we use Greek letters is because it avoids any confusion about what we're solving for. So if I say solve for beta, you know, oh, he said a Greek letter, that means it's an angle. Some textbooks, the way they do it, is they use lowercase letters for the sides and capital letters for angles. That can get confusing. Because then if you ask me, like, if we're doing lowercase and capitals, you have to say, like, how did you get capital A? Or how did you get lowercase a? Right? So this way, there's less confusion about what we're solving for. And the other downside to that is, depending on what letters you pick, capital and a lowercase letter can look the same. So that's another problem. Here, we don't have any letters or any symbols that look the same at all. Okay, so any question on our diagram? Yes?
What's the one in the like tiny corner called?
In the lower right,
Yeah.
that's alpha.
Okay, thank you.
You're welcome. A-L-P-H-A. The one at the top is beta. B-E-T-A. And this week, we don't need a label for this side. We can just call it the right angle. But eventually, we're going to solve triangles where that's not a right angle. And then we will have to give that a name. But not this week. All right. So this says solve the triangle. This is an example of the first case. I said there are two different kinds of problems I could give you. This is one where you have a side and you have an angle. So what did I say was the first thing that you want to do in this kind of problem? So we're going to have to figure out like opposite and adjacent and that kind of stuff. Yes?
Would you set up the diagram first?
Yeah, we're going to set up the diagram. So again, it's not to scale. We're just going to replace the labels in this diagram with what we were given. So B is 2. Beta, we don't know. Try to draw that a little better. Alpha, we do know. It's 40. A, we don't know. C, we don't know. So all I've done is label on that diagram everything that was given. A is across from alpha, B is across from beta, and C is across from the 90. Okay, questions on the diagram? So now, let's set up a table. So the table is just to organize all our answers when we're done. So they're all in the same spot. Okay, we'll do all the work below the table. So I put A, B, and C for my sides, alpha, beta, and then the right angle, which I already can fill that in is 90 degrees. All right. So you can find anything you want in any order you want. I tend to get the easy ones out of the way first. So does anybody see something there that would be pretty quick to solve for? Wouldn't really require anything that I've taught you in this class. Jacob?
Beta.
Yeah, how could we get beta?
Adding up all the angles that we have, subtract them by 180.
Yeah, you just add everything up, subtract it from 180, and there's the answer. And we know that these two angles, alpha and beta, what do those have to add up to?
90.
Those have to add up to 90, because we can just take the 90 out right away for the right angle. So for alpha and beta to add up to 90, what does beta have to be? Then?
50.
50. Okay. So there's our first angle, 50. Questions on that? All right, now we can find A or C. It doesn't matter which one we do. Let's do A first. So I'm going to circle in the diagram what I just said I want to find. I want to find A. And what I'm going to use to do it is the 2 and the 40. Anytime you're solving for something using trig, there's always 3 things involved. 2 things that you know, and one thing that you're trying to find. Now, technically, I could have used beta, because I know beta at this point is 50. But why do you think it might be a bad idea to use this to find A? There's a reason why. Yeah?
If you were given the other one, you probably want to use that one because there's a chance that you might have calculated it wrong.
Yes. If this is wrong, I mean, I know it's right because it's an easy enough calculation that 40 plus 50 is 90. But let's say you accidentally wrote 40 here. Well, if that's wrong and you use it to do other things in the problem, now you're going to get everything in the problem wrong. Okay? So in these kinds of problems, don't ever use something that you calculated to figure out something else. Always go back to the information you were given. Okay. Any question on that? All right. So now we're going to find A using the 40 and the 2. First thing we want to figure out is what are these two sides? Okay? What are their names? And by names, I mean opposite, adjacent, or hypotenuse. Let's start with A. Out of the 3 labels I just said, which one would we use for A? And keep in mind, you're standing at the 40-degree angle. That's the angle we're using. Yep, Pete?
Opposite?
Yep, this is opposite. And what about the side that is 2? Yep, that's adjacent. By identifying those two sides, we now can figure out which trig function we want to use. You always use sine, cosine, or tangent. Always one of those 3. Because those are the ones we have buttons for on the calculator. So look in your notes, or if you remember it, you can also just tell me. Which trig function out of sine, cosine, or tangent has opposite and adjacent? Lacey?
Tangent.
Tangent. So we're going to set it up using tangent. What you fill in right there is always the angle. So the tangent of your angle, 40 degrees, equals, and now use the definition I gave you yesterday, opposite over adjacent. So opposite in this case is A, adjacent is 2. And now we just have to solve that equation to get A by itself. So the only problem with it is we have this 2 on the same side. We don't want that 2 there. So Raymond, how would I move that 2 to the other side?
Multiply it.
Yep, multiply by
2.
2 times 2 times 2. And there is your answer for A. We need to type that in. In this section, they're always going to say round to 2 decimal places. Okay, so a little different than how they had us do it yesterday. We'll round that off. All right. So let me show you how my calculator screen looks. What should I do before I even start typing the problem in? Yep.
Change to degrees.
Change to degrees. I could type it in this way and it'll give me an answer, but it'll be wrong. So we want to change to degrees. Every problem that we do today is in degrees. And every problem of this type will be in degrees. I'm not saying there won't be other problems in radians from what we did Monday and Tuesday, but the Wednesday problems on the test will be in degrees. Put in degrees, type in 2, tangent, 40, and we get 1 point, we'll go with 3 decimal places, 6, 7, 8. So A is 1.678. And that's it. Okay. Any questions on A? Okay, so now we're down to our last piece of information we need to find. I have 2 out of 3 of the sides. So what theorem could I use to get the third side now? Pete?
Pythagorean.
Yep, I could use the Pythagorean theorem, but why do you think I think that's a bad idea? James?
Because one of the lines is a decimal,
And what's wrong with it being a decimal?
it would just be annoying to work with.
Okay, what else?
I don't know.
Anybody comment what else? You said because it's a decimal? I mean, I'm going to use a calculator, so I don't have to do anything by hand. So the calculator is going to do all the hard work for me. But why else would I not want to use 1.678? Yep, James.
Is it because it's to 3 decimal places?
What's wrong with it being at 3 decimal places?
Would it be rounded to 2 decimal places?
I could round to 2, I didn't, but I rounded to 3. Is there a problem with that?
No.
Yeah.
Because it could be wrong.
Okay, so that's one very important reason. This could be completely wrong. Maybe I messed up the whole thing. And now if this is wrong, and I do Pythagorean theorem, well guess what? Now C is wrong too. And the other reason, which I thought we're kind of going to get to, but I'm not sure we got there, is because this is rounded, it's not completely accurate. There's no problem with rounding something, unless you're going to round something and then use it to do something else. Now you're using a number that's not accurate to get this. So now this is not accurate. Right? Yeah, I mean, it's 3 decimal places, so it's better than 2, but it's still not perfectly accurate. Right? So to find C, we're going to go back and circle what we want to find. And I'm going to focus again on the 2 pieces of information that we're given. So the adjacent is the given side. So I'm still using adjacent. But now I don't want to do anything with opposite. I'm done with opposite. I want to do hypotenuse. Right? So this was the work to find A. Now we'll find C. So think about what trig function I would use. You have sine, cosine, and tangent. We already used tangent, so we're not going to use that again. What trig function would have adjacent and hypotenuse in it? Yes, go ahead.
Cosine.
Cosine. So we're going to set it up now with cosine. So cosine of, and Colby, can you tell me what's going to go in the parentheses?
40.
40. Remember, this does not mean multiplication in any way at all. It just means take the number 40 and plug it into that formula, or that function, cosine. And cosine is adjacent over hypotenuse. Adjacent is 2. Hypotenuse is C. A little different because the variable ended up in the bottom. That's okay. We can still work with that. So how about Cassidy? What would be my first step if I just wanted to get rid of the fraction on the right-hand side?
To get rid of 2.
Well, the 2's okay, because that's not, I just want to get rid of the fraction, which means I just need to get rid of what's in the bottom.
So multiply
Yeah, what would you multiply each side by?
C.
C. And just so we can remember what we started with, what's in green was the original problem. So keep that in mind. So times C on the right, that gives me a 2. And on the left, I have C cosine 40. Now, I have C times something. I don't want to have this times cosine 40. So how about Mateo? How would I put this cosine 40 on the other side? Well, what's preventing the C from being by itself?
The cosine 40.
And And what operation are we doing between the c and the cosine 40?
Do multiply.
So what operation cancels out multiplication?
Divide.
Yep, so we're gonna divide. And what would you divide each side by to get rid of what's next to the c?
Divided by cosine 40.
Yeah, divide by the cosine of 40. What is the cosine of 40? I don't know. I don't need to know. All I need to know is divide each side by it. And that's gone. And here is our final answer. 2 divided by cosine 40. I still don't need to know what the cosine of 40 is. I'm never going to figure that out in this problem. I'm just going to type that whole thing in and get the answer. I want to know 2 divided by cosine 40. So 2 divided by cosine 40. That's how you want to type it in. And you end up with 2.611. 2.611. And we're done. We've solved the problem. All right, so you can get partial credit for each one that you get right. So this really is like 3 different parts to this problem. When you're done, there's a couple of quick things you can look at to make sure nothing is obviously wrong. In a triangle, any 2 sides added together should always be bigger than the third. If that doesn't happen, then you did something very wrong. Okay. Any 2 sides added together should come out bigger than the third. And that works here. 1.6 and 2 is 3.6. 2.6 plus 2 is 4.6. And 1.6 plus 2.6 is definitely bigger than 2. So that works. The other thing you can check quickly is the biggest side should always be in the same row as the biggest angle. The smallest side should always be in the row with the smallest angle. If that doesn't happen, then something else is wrong. Okay. Any questions on that? And a third thing you could do to check this, if you had time, is you could try Pythagorean Theorem now. A squared plus b squared should equal c squared. If it does, then that's a way of checking all these answers. Or it'll be approximate, because remember, these are all rounded, so it might be close. The other thing I want to look at is, look at the green boxes. Does anybody see how we could get from green box 1 to green box 2 without having to do this step in the middle? Look at what ended up happening. If you just wanted to describe how green box number 1 compares to green box number 2. Yeah?
The cosine of 40 just swapped with the c.
Exactly. The cosine 40 and the c just swap places. So that's a shortcut that I'm going to use from now on. Anytime we end up with a variable in the bottom of a fraction, you can always swap that letter with what's on the other side. The reason why? Well, we went through all the work right here that shows that. Okay, so any questions on that one? All right, so let's try another one of the same type, and then we'll do one of the different type. All right, so solve the triangle. Okay, so A is 6, B and C we don't know. Alpha, we don't know. Beta is 20. And of course, the right angle is always across from C. All right. So how about Ava? Whenever we have to solve a right triangle, what did I always suggest you do first?
Draw it out.
Yeah, let's just draw it out so we can kind of see what's opposite, what's adjacent. Let's make our sketch. Again, you can draw your sketch with the triangle facing a different way. That doesn't matter. When you label it, just make sure A is across from alpha and B is across from beta. That's the important thing. So if we put A here, we have to put alpha there. If I put B, then I have to put beta right there. C and gamma. The right angle. We're going to call this gamma in 2 weeks. Okay, but for now, we just call it the right angle. Okay. All right. How about Katrina? Is there anything I can find first that would be pretty quick?
The third angle.
The third angle. What's the third angle going to be?
70.
70. Okay, everything has to add up to 180. So this has to be 70. Okay. Now that I know that angle is 70, Olivia, should I use that angle to find other things?
No.
No, why not?
Because we just found that.
And what's wrong with us finding it?
Because it might not be right.
Yeah, it might not be right. Okay, so forget about it. We found it. We're going to use the 20, and we're going to use the 6 to find everything else. Ben, what do you want to find first? B or C? B. Okay, so we're going to find B. So we have to figure out what trig function to use. And the traces are sine, cosine, or tangent. So Dominic, what trig function would I use here? All right, let's label our sides first. What is this bottom side if we name it relative to the 20-degree angle?
Opposite.
This is opposite. And what's the name of the side that's labeled 6?
Adjacent.
Adjacent. What trig function has opposite and adjacent in it?
Sine.
Sine is opposite and hypotenuse.
Cosine.
That's adjacent and hypotenuse. Yep, Ava? Tangent. Tangent is opposite over adjacent. All right? So tangent of my angle, in this case, 20 degrees, equals, Raymond, can you tell me what's going to go on the right-hand side?
6 go at the bottom,
Yes.
and then B on top.
Yep. So opposite over adjacent. This is the case where the letter is in the top, so all we have to do is multiply both sides by the number in the bottom. Times 6, times 6, and there's your answer. We just type that in. Okay, make sure your calculator's still in degrees. Yep, looks fine. 6 tan 20 gives me 2.184. Okay, if I round properly. 2.184. And that is B. All right, so now we've got 5 out of 6. We want to find C. All right, so James, I got 2 out of 3. Should I use Pythagorean Theorem to get C?
Yes.
Okay. I'm going to say no. And I want you to argue with me why. Why? Let's pretend I said yes. So tell me why I'm wrong. Why would it not be a good idea to use Pythagorean Theorem?
Oh, because you round it, so it cannot be totally accurate, so you can get the wrong hypotenuse.
Yeah. So this isn't completely accurate, and it could be completely wrong. Maybe the real answer is 5.614, and we wrote 2.184. That's totally wrong, right? So we're going to go back to the two pieces of information that were given. So we're going to use the 6, we're going to use the 20, and now we want to find the C. Okay, so focus on what I circled in blue. Okay, we're using adjacent again, but Colby, what other side, besides C, what side is that? Hypotenuse. And Lacey, what trig function has adjacent and hypotenuse in it? Cosine. Right. I'm using adjacent because that's the side I know. I'm using hypotenuse because that's the side I'm trying to find. I'm not doing anything with opposite on this one. So, cosine. Alright, so this first one, we'll just write down what we did. This was to find B. Now let's find C. Cosine of, Jacob, what's my angle?
20%. 20 degrees.
20 degrees, yep. Equals. And Cassidy, what's my fraction going to be on this side?
That one is going to be. No, wait. Hold on, I'm a little lost.
So what's the definition for cosine? It's
Adjacent over hypotenuse.
yes. What's my adjacent in this one?
6.
And my hypotenuse?
C.
C. Good. So now this is the one where we can use that trick that Pete recognized earlier. We just switch the C and the cosine 20, and there's our answer. 6 divided by cosine 20, and you're good. That's it. Okay, just type it in and see what you get. 6 divided by cosine 20. That's 6.385. All right, so let's check. Is the biggest side across from the biggest angle in this case? Tail lever.
Can you repeat that?
Is the biggest side in the same row as the biggest angle?
Yeah.
Yeah, that looks good. How about is the smallest side in the same row as the smallest angle? About Jess?
Sorry, what?
Is the smallest side in the same row as the smallest angle?
Yes.
Yeah. So that all looks good. If I add any two sides together, it should come out bigger than the third. 6 and 2 is 8, which is bigger than that. 6 plus 6 is 12, which is bigger than that. Yeah, everything looks good. All right, so any questions on solving the type where you have an angle and a side at the beginning?
Can you just scroll back down for a second?
So there's something we learned this week that we haven't even used today. What have we been learning all week? What have we been learning about that we haven't used yet? Inverse. Okay. None of these problems require the inverse. The next problem, well, let's see what happens. So Katrina, what's different about the information that they give you this time?
They give you 2 sides and an angle.
Yeah, they give you the two sides to start with. Okay, we always have the 90, but they're giving us the two sides. So this is a different setup. Okay, so we're going to do things in this problem a little differently than the last two. So let's start with our diagram. Okay, we'll put A alpha, B, beta, C, and my right angle. All right. Any thoughts on something we could try to find first? Technically we can do anything first, but which one do we want to try for first? B?
I think it'd be easier to find C first.
Okay, let's find C. How could you find C?
A squared plus b squared is c squared.
Okay, now I thought before I said I didn't want to use Pythagorean Theorem.
Well, this time we have whole numbers that we know are followed by all zeros.
Okay,
And they're just whole numbers, and we know that we can't really mess it up because
why can't we mess it up?
they gave it to us.
They gave it to us, right? Well, I mean, we can still mess up the calculation, but we can't mess up the stuff we're plugging in because it's given. So this time, I'm okay with Pythagorean Theorem. So this is to find C. So a squared plus b squared equals c squared. A squared, b squared equals c squared. And remember, these kinds of problems, it is okay to round it to 2 decimal places. Or 3. I think we're doing 3. So we get 9 plus 4 equals c squared. I think this looks just like one we actually had in the homework last night. So what is c in this case? Yes?
Square root of 13.
Yep, it's the square root of 13. And they are going to ask you to round that off, so let's type that in. Square root of 13 is 3.606. So 3.606. Okay, any questions on how we got C? All right. Now, Olivia, should I use C to find alpha or beta? No, how come?
Because it didn't give to us.
Yeah, it wasn't given to us, and it could be wrong. So, I'll circle 2 things I'm going to use. And Angelina, I'll let you pick. Do you want to find alpha or beta? All right, let's find alpha. So Ben, from the perspective of alpha, what's the name of the side that's 2 units long? So the choices are opposite, adjacent, or hypotenuse. It's adjacent, and how about the side that's 3 units long? That's opposite. And Dominic, what trig function involves opposite and adjacent?
Tangent.
Tangent, good. So we're still using 3 things, but look at what the variable is this time. It's not one of the sides. You know both the sides. The variable is the angle. That's never happened before. And since that's never happened, we're going to have to solve it in a way that's a little bit different. So, find alpha. So we're going to use tangent. We always fill the angle in. So this time it's tangent of alpha equals opposite over adjacent. 3 over 2. Now I have to get alpha by itself. Raymond, what's preventing alpha from being by itself right now? Okay, so there's parentheses. What else?
I don't know.
Like, what's preventing x from being by itself in this case?
Square root.
The square root, because there's something there. What's preventing alpha from being by itself in this case?
Square root.
Well, let me erase that. In this case. Because it doesn't say this, right? So what's what's there with the alpha that makes it so alpha is not alone? The tangent, right? It has a tangent of alpha. So you're doing something to alpha. You're performing that function on alpha. We don't want to perform that function on alpha. We want to get rid of tangent. So how can we get rid of tangent? Yep.
Find the inverse tangent of both sides.
Exactly. We're going to take the inverse tangent of both sides. Just like this was your problem. Like when we do Pythagorean Theorem. So just do, look at this one right here. 13 equals c squared. You're performing the squaring function on the letter c. We don't want to do the squaring function. So how do we cancel it out? We use the square rooting function. Take the square root of what's on the right, take the square root of what's on the left. And then those cancel. Same thing here. Take the inverse tangent of everything on the left, take the inverse tangent of everything on the right. Inverse tangent and regular tangent cancel out, just like square and square root. Now, we have alpha equals, and remember what inverse tangent is always used to find. I mentioned that on Monday. It's always used to find an angle. That's what we're doing, finding this angle. Inverse tangent of 3/2. And now type that in. So second inverse tangent, 3 divided by 2. That comes out to 56 point, if we round it, it's 310. That's going to round up. 56.310. Now, if we were running out of time on the test, I would say just subtract that from 90 to get beta and hope that you got alpha right, because if you didn't, then you're going to get beta wrong. But let's find beta exactly the same way we found alpha. Stick with the two sides that we know. So I'll stick with this one. But now we're doing beta. Something different happens here. You're not using alpha anymore. So what you've done is you've just switched your perspective. You're not standing in the same spot because now we're solving for a different angle. Those names don't apply anymore because now it's from the perspective of beta. So what is the side that's 2 now? Yep.
2 is now the opposite and 3 is now adjacent.
Yep. And 3 is adjacent. So we're still using opposite and adjacent. It's just they switch places. So we're still going to use tangent. So let's set it up. So I'm going to find beta. And it's tangent of my angle equals. And what's going to go on the other side this time? Okay? 2 over 3. Opposite over adjacent. And you're going to solve this exactly the way you solved the one up above. You're going to take, there is no multiplying that's happening anywhere in this problem. Take the inverse tangent of both sides. Just try to squeeze it in there. And there's my answer. Inverse tangent of 2/3. Now, if we did it right, we can check it. The answer should be 90 minus 56.31. Let's see what that is. 90 minus 56.31. 33.69. So just keep that number in your head for a second. 33.69. Let's type this in on the calculator. Inverse tangent, 2/3, 33.69. So since I got the exact same answer doing it 2 different ways, taking my original and subtracting that from 90, and with inverse tangent, that means my answer must be right. So 33.69. And that's an example where you have to use inverse trig. So anytime that they start you off with two sides, you're going to have to use inverse trig. If they start you off with a side and an angle, don't have to use inverse trig at all. Yes?
You can scroll down.
Yep. I think there's a line in it. I don't know how that happened. And the last question we'll look at is a word problem. But I think as long as we make a diagram, then it's pretty straightforward. Okay, anyone else need to copy anything else? All right. So, it says that you lean a 20-foot ladder against a house. So hopefully you know that if you have a 20-foot ladder, you can't put the ladder perfectly vertical. You have to put it on an angle so it doesn't fall. But because you put it on an angle, the ladder won't reach as high. Right? It's on a little bit of an angle. So we're going to have a 20-foot ladder leaning against a house, and the angle between the house and the ladder is 17 degrees. How high will the ladder reach? Basically asking, how high will the top of the ladder be against the house? Right, so Colby, what do you think I should do with all this information to make it easier to think about?
All right.
Yeah, let's draw it out. So, Lacey, what's something that's going to be in my picture when I draw it?
The 17, a 90 degree.
So let's think just in terms of objects in it. Even more basic, just the objects in the picture.
Why didn't you just draw a triangle? Or are you drawing the ladder against the house?
We're going to actually draw a little scene here, yeah.
Oh.
So we're going to draw a ladder against a house. So I need a ladder, I need a house, I need something else. Yeah, I need the ground. So that's the most basic thing I need. So let's start with the ground. There's my ground. All right, here is my house. Crooked house. Good enough. So there's my house. And now I'm going to have a ladder leaning against it. Like that. So the goal here wasn't to draw a triangle. The goal was to draw this picture, and then a triangle will happen automatically. Can somebody tell me something else that I can label in that picture? Yep.
I don't want to assume, but I'm pretty sure that the ladder in the house will have a 90-degree angle.
So the ladder. So the only point where the ladder and the house touch is right there.
But to the ground.
Okay, so the house and the ground
Right.
make a
yeah,
90.
Yeah.
Yes.
In the right.
So yep, the house and the ground, we'll assume that that makes a 90. Anything else I can label? Jess?
The hypotenuse is 20.
So the ladder is really like a hypotenuse. I didn't want you to think of the ladder as the hypotenuse, but that's just naturally what happens in the picture. So the ladder is 20 feet long, and then anything else I can label. Yep.
The angle between the ladder and the house is 17 degrees.
And where is the angle between the ladder and the house? At the bottom or at the top? It's at the top. So this angle is 17 degrees. So let's draw this triangle. Right there. That's the triangle. So now I'm just kind of taking that out of the word problem and making it its own thing. This is 20. That's 17. That's 90. And what do I really want to solve for in that triangle? To be able to answer the question. Yep.
The side on the right.
Yeah, the side on the right. I want to know this. From here to here. Call that A. How high will the ladder reach? All right. So here's my two pieces of information that were given. Here's what I want to know. Without me kind of leading you through it step by step, can anybody tell me which trig function that I would use? James?
The cosine?
Yeah, you're going to use cosine. Cosine of 17 degrees equals, and can you tell me what would go on the other side?
A over 20.
Adjacent over hypotenuse. Multiply each side by 20, and there's your answer. So if you put the ladder on an angle, is it going to be able to reach higher than 20 feet or less than 20 feet? Just think about it from like common sense. Less, right? It's going to be a little lower. So if this comes out a little lower than 20 feet, or is it 20? Okay, I thought it was 25. No, it was 20. Let's see what this comes out to. So 20 cosine 17 makes sense. Comes out to about 19.13 feet. So putting it on that much of an angle, you can't. The top of the ladder won't be quite at 20 feet. It'll drop down a little bit. Okay. Any questions on that? Anybody have a guess at what this angle would have to be so the ladder would only reach half as high? So the ladder would only be 10 feet? Yeah?
45?
You might think it's a 45, but actually at a 45, the ladder would still reach maybe about like 15, 16 feet. You'd actually have to make that angle 60. That angle would have to be a 60-degree angle before the ladder would only reach 10 feet off the ground, which that'd be impossible. The ladder would stay against the house. But that's kind of weird. You might think it's a 45 because 45 is half of 90, but it's actually 60. So, not necessarily an intuitive question to think about. All right, so homework tonight is on page 255. It's 31 to 39 odd, 43 to 47, 51 to 55 odd. So again, just to summarize, what's going to be on the test. And this will be for tomorrow. We'll start it at the end of class and we'll finish it on Friday. You want to know how to do inverse trig. Both looking it up in a table. Okay, the table will be as a picture in the question on the test. And using a calculator. You want to be able to write the 6 trig functions. So if I give you a diagram and I say what's the sine, the cosine, the tangent, all that stuff. What else is on there? The complementary angle theorem. That's something we did at the end of class yesterday. Let's see. And then the last thing will be solving right triangles. And that's what we did today. Okay, so those are the main topics that'll be on the test. I'll post this video. I'll try to do it pretty soon. I have a meeting in 4 minutes, so I might not get it posted before I leave for that. But I will save it and I will post it before end of the day.